Hi guys, so today we're going to do a tutorial of this question. LeetCode 220 contains duplicates tree, right? So what's interesting about this question is that it's one of the first questions that I could solve, the first hard questions that I could solve on my own without having to look at the solutions. So it took me about 40 plus hard questions, less than 50, probably about 40 to 45 before we're here. So I'm pretty happy about that. But anyways, let's get to doing it. And the solution that I came up with, it's in linear time and in constant space. And what I like about it is that a lot of other YouTube solutions, after I finished that, I went to check, a lot of them did it maybe in n squared time. And the problem with that is that the new test cases, because of the nums length being 10 power 5, the n squared will result in like a 10 power 10 or 10 power 9, 10 power 10 kind of computation, which will lead to time limit exceeded. So we have to try to do it in either linear time or n log n time, and I think the solution I think it's in linear time, but yeah, and let's see it, right? So before that, let's take a look at the question. So we have a pair of indices I and j and an integer array nums. Find the pair such that I does not equal to j and the absolute value of I minus j is lesser than the difference between the indexes of I and j, and the absolute value of the numbers that the index is pointing to is less than or equals to the value difference, right? So some examples: index difference 3, value difference 0, right? So 1 and 1, that could be 1 and 0 and 0, 1, 2, 0 and 3, and the three conditions are satisfied basically because 0 and 3, the absolute value of that is less than or equals to 3, and the value difference is 0, right? Same here, index difference 2, there are no possible ways that this can be satisfied if you try it out, no matter how you try it out here. So I think what's interesting about this is that I don't think this question conceptually is actually that challenging, but I think because of the time limit exceeded thing and the fact that LeetCode increased the number of test cases a few years after, and also the fact that it is a bit tricky, so therefore I think that it can trip people up a little bit. So we have these variables I and j. So I is going to be the first pointer and j is going to be the second pointer. But the reason why a lot of the other tutorials on YouTube I think are interesting is because when you go to the related topics, this sliding window is here, and that's what I used. But I did not use sorting, bucket sort, or ordered set. So that enabled me to just create these two variables. So the space usage will be constant, and I hope that it's in linear time. Should be, because even when the sub loops run, it is in linear time, but the number of times they run is inversely proportional to the size of the sub loop. So it should be in 3n time or 2n time, which is basically n time. So anyways, while j is lesser than nums.length, so j is basically the second pointer, right? And at the end, if nothing happens, we just return false. So what happens in this loop? Now first we need to have the terminal condition. So basically, if math.apps, but I'm using JavaScript, this will work with any language, is less than or equals to index diff and math.absolute nums I minus nums j is lesser than equals to value diff, then you can return true, right? So this is the terminal condition. But in creating, before we reach this terminal condition, there are two possible conditions that can happen. Either, so if this is not met and this is not met, then there are two possibilities for this, because this will always be met in some way while this is happening. Either by the way, this starts at 1 because j is the second pointer, so it's always ahead of the first pointer I at 0. And the two conditions that can happen, when this is not met, is that basically either it's lesser, or which means that it's lesser or it's equal to index diff. Okay, so those two need to be handled separately. So let's do if it's equal to index diff first. So an example is like when the difference is 2 and j is incremented to like a distance of 2 from I. So j is always ahead of I. So let's just say right now it's equal. What you need to do is you need to then shift I towards j. Okay, just imagine this is I. Shift, okay wait, let's imagine this is I. Shift I towards j, such right until the point whereby it's 1 square below j. So while I is lesser than j, right? If basically, but you only need to check if this condition is true, then you can return true, right? And in the meantime, you just increment I. But at the end, when it's 1 below, you need to reset I not to the initial position, because the initial position we already checked and that this is not fulfilled, but this is fulfilled. We need to increment I by 1. So what we need to do is create a const variable called temp, and you can just set that to I, and then in the end you just set I equals to temp plus 1, right? Which would make a lot of sense, because then you are just shifting the I position up by 1 from the start. And basically what this loop does again is now equal, but then this condition is not met, right? So it's now equal to the index diff. So you increment I all the way until it's 1 below, right? And then each time you increment, you always check, okay, is this condition met? If it's met, true, right? Now you just keep incrementing until it's 1 below, right? Then at the end, when it's still not met and it's still lesser than j, you reset I back to the temp value at the start, but you increase by 1 because that initial index diff difference already been checked. So that's the case whereby they are equal to the difference in index diff. Now the other case is, what if they are lesser than index diff? Now we handle it in a very, very similar fashion, whereby we check if this is the case, right? Because that's what you need to do, right? While I is less than j, you just keep incrementing. But what happens? So what? Okay, an example of this is, let's just say the index diff difference is 3. So now we're checking if index diff difference is lesser, so it's 2. But this condition is still not met, but it's not equal, but it's 2. So you need to increment it. So let's just say now you increment it, now the difference is 1, right? You check, okay, it's still wrong, I plus plus. But you can't plus anymore because I is less than j. So what do you do in this case to I again? You just reset I back to the original value. So again, we create a temp variable called I, and after it's done being incremented, all you have to do is reset it back to the temp value. Now let's try running it on the 2 test cases that we have first. It's accepted. Let's try submitting it. Okay, great. So the memory is actually in constant time. I don't know why it's not showing up better, but anyways, the runtime is beats 57.4881%. But anyways, let's take a look, because okay, space complexity is fairly simple because you don't create any new data structures, so it's in constant time. But for time complexity, okay, this one will run in linear time, right? And this one, the argument is you'll run in the difference between I minus j times. And that's correct, right? But what is I minus j? Could it be as big as the nums.length? Yes. But in that case, how many times will it really run if it's as big as nums.length? The answer is it's only going to run 1 time. Why? Because that's when it's equivalent in length. Now, for this particular part of the algorithm, it is smaller, lesser in value than index diff quite often if it's going to be the same size as index diff. So yeah, it's gonna run again in 10 to the power of 5 time. So yeah, probably it's actually not as fast as I thought. It might be in n squared time. That's unfortunate, but I guess it was still accepted. So, and it's a fairly simple solution compared to other solutions out there. But anyways, thanks so much. Have a good day. Bye.